Today we're going to look at index laws 4 and 5 and negative indices. So index law 4 looks at if we've multiplied two values inside a set of brackets and then all raised it to the exponent here m, what does that actually look like? Because we can have a bit of a shortcut. This is the law, shortcut that we can use, and this is where it comes from. The definition of this means that if we've got a times b all raised to the power of m, it means we've multiplied ab times ab times ab m times ab times ab times ab times ab up to m times. We can rearrange this so that all of the a's are together and all of the b's are together. So we've got a times a times a times a m times and b times b times b times b m times. So that means we've got a lots of m lots of a, m lots of a, a times a m times, and b times b times b times b m times. And then we can multiply those together. So it looks like, in effect, we have expanded out our a times b all to the power of m. We get a times a to the power of m times b to the power of m. Index law 5 is very similar to index law 4, except it involves division or a fraction. So here we've got a divided by b, all raised to the power of m. So that's a divided by b times a divided by b times a divided by b, etc. m times. So we have a times a on the top and b times b on the bottom. A times a multiplied by itself m times and b multiplied by itself m times. So that's just a to the power of m divided by b to the power of m. Exactly the same kind of expanding out kind of idea, but this is where it comes from. This is where these index laws come from. If we look at negative indices, it's always helpful to try and see patterns in mathematics. So let's have a look at what happens as we reduce the index by 1 each time. So we've got 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0, etc. all the way down. So 2 to the power of 3, 2 times 2 times 2 is 8. 2 to the power of 2 is 2 times 2 is 4. So you can see if we look at 8, then 4, then 2, then 1, we're dividing by 2 each time. That's the pattern that we see. So if I take the 1 and divide it by 2 again, I get 1 over 2. If I take 1 over 2 and divide it by 2 again, I get 1 over 4. If I divide that again, 1 over 8. So you can see our pattern continues. You can see that 2, 4, 8 is here, 2, 4, 8. So that means this is 1 over 2 to the power of 1, 1 over 2 to the power of 2, 1 over 2 to the power of 3. So our same pattern. Now 2 to the power of 3 is 8, 2 to the power of 3 is 8. So we can see a relationship here. And now we can look at the actual relationship between the negative index and its reciprocal here. So you can see here, negative index, negative 1, 1 over 2 to the power of 1. Negative index here, negative 2, 2 to the power of 1 over 2 to the power of 2. So we have this relationship, and this is another shortcut or law, but this is the reason, this is where it comes from, of a relationship that we can see. If we've got a negative index, if we have a negative index, the reciprocal of it will have a positive index. So it means that if I've got a to the power of negative m, that's the same as 1 over a to the power of m, a positive index. And if I've got 1 over a to the negative m, the reciprocal of that is the positive index here. So I could express here 2 to the power of 3 is exactly the same as 1 over 2 to the power of negative 3. Okay, so these two relationships are reflected in the pattern that we've seen with our indices. Let's have a look at some examples. So we've been asked to expand these following expressions, and what we need to do as well, we need to make sure our answer is expressed in the simplest form possible. So 4 times, in brackets, c squared times d cubed all to the power of 5. Now the power of 5 doesn't include the 4 here. The 4 is not inside the brackets, so the 4 just stays out the front, and we don't need to do any expanding of that at all. However, the 5, we can expand out the first term here and the second term and do c squared to the power of 5 and d cubed to the power of 5. So that's what I've done here. C squared to the power of 5 and d cubed to the power of 5. Now we can use index law 3, which says that if I've got a power raised to a power again. These two multiply. So here I've got 2 times 5 is 10, and 3 times 5 is 15. So all of this simplified gives us 4. The 4 out front, which didn't have any operations on it. C to the power of 10, D to the power of 15. Looking at our next example here, what we see is we have everything in the brackets is raised to the power of 4. So we can treat each element individually, our -2, our a squared, our 3, our b, and our c to the power of 3, and raise each of these separate elements, which are either multiplied or divided together, to the power of 4. So here you can see I've done that. -2 to the power of 4, our a squared to the power of 4, our 3 to the power of 4, b to the power of 4, and c cubed to the power of 4. So each of these elements I can then expand out or simplify. -2 to the power of 4 is the same as -2 times -2 times -2 times -2. If we put it in our calculations, we need to make sure the -2's in brackets. -2's in brackets, because negative times a negative is a positive. Because I'm multiplying 4 negatives together, the end result will be positive. So the end result here is 16. Okay, it is a positive result. A squared to the power of 4, multiply those two together by index law 3. 2 times 4 is 8. The b to the power of 4 just sits by himself there. C to the power of 3, all to the power of 4. Once again, 3 times 4 is 12. So here I've got 16 times 8, a to the power of 8. On the top of our relationship here, of our ratio, 81 times b to the power of 4 times c to the power of 12 underneath. Now, and once again simplifying, you'll notice here I've been very careful. I need to double check that 16 and 81 here, 16 and 81 don't have any common factors that I could divide the top and the bottom by. Otherwise, it wouldn't be simplified. But they don't. The highest common factor of 16 and 81 is 1. So we're not going to be able to divide either of those. So that is as simplified as we can get. Our last example here is going to be multiplying these two fractions together. So if we remember multiplying fractions, we can just multiply everything on the top row and the bottom row, which is going to be super easy and helpful for us here. So we can expand out everything in this set of brackets to the power of 3, and everything in this set of brackets to the power of 4. So if we look at this set of brackets, we've got x to the power of 6, because we've got 2 times 3. Y to the power of 9, because it's 3 times 3, and c to the power of 3 here on the bottom. If we have a look at this part here, everything to the power of 4. X to the power of 4, c to the power of 4, y to the power of 4. Now, in order to simplify this, I've got c to the power of 3 on the bottom and c to the power of 4 on the top. So that's like saying I've got c times c times c times c. C times C times C times C on the top, and C times C times C on the bottom. So 3 of those C's cancelled, leaving 1 C on the top. Here I've got 9 Y's and 4 Y's on the bottom here. So I can use essentially index law 2 to cancel those out. 9 minus 4 is going to be 5. So I'm cancelling out because there's Y's on the top divided by Y's on the bottom. Y divided by Y is going to be 1. So 4 of those Y's are going to cancel, and we're going to be left with only 5 on the top there. So we're left with, from index law 1, x to the power of 6 times x to the power of 4 is x to the power of 10, y to the power of 5, because we've got the 9 minus the 4, and c to the power of 1, which is just c, because we've got 4 on the top here, minus the 3 on the bottom, so we're left with just the 1. Our second example here has us expressing these expressions with positive indices. So our first one here, the negative index is a to the negative 2. A to the negative 2 is the same as 1 divided by a to the positive 2, because we can find the reciprocal of that will be a positive index. So we leave the 3 and the b to the power of 4 on top because they're positive, they don't have positive indices or no indices at all. And our a to the negative 2 becomes divided by a to the power of 2. 1 divided by c to the power of negative 2 is just exactly the same as c squared, c to the power of 2. So we've converted that to a positive index here. Here I've got x to the power of negative 3 divided by y to the power of negative 5. If we just have a look at x to the power of negative 3, that's going to be the same as 1 divided by x to the power of 3. And if we look at our y to the negative 5, that's going to be the same as, because we've divided it by, that's going to be the same as just y to the power of 5. Lastly here, the only negative index, the only thing that we need to worry about is our y to the power of negative 4. That, if we look at the properties of negative indices, to make it a positive index, we're going to take it up the top and leave it as y to the power of 4.